Actually, just right after stopping that video, I realized a very simple way of showing you that RP is congruent to TA, a little bit more of a rigorous definition. If we can show that this triangle, if this triangle right there, that one I drew in purple, and this triangle I drew right here are congruent, this triangle right there are congruent, then I think we can make a fairly reasonable argument that RP is going to be congruent to TA, because they're essentially the corresponding sides of the two congruent triangles. These congruent triangles would be kind of flipping each other, right? So how can we make that argument? Well, on the purple triangle, this angle is going to be equal to this angle on the yellow triangle. And actually, we got that from the fact that this is an isosceles trapezoid, so the base angles are going to be the same. They told us it's an isosceles trapezoid, so we know that this side right there is going to be congruent to this side, right? And then finally, they both share this side right here. They both share this side. So we could use the argument, once again, side, angle, side, that the side, angle, and side are congruent to this side, angle, and side. So you could, if we're doing it in, we could say by SAS, triangle TRP is congruent to triangle what? TAP. And if they're congruent, then all of the corresponding sides are equal. So then TA is congruent to RP. But once again, you didn't have to do all of that. It's a multiple choice test. But I wanted to give you, I felt bad that I wasn't giving you a more rigorous definition. But anyway, more rigorous proof. So anyway, problem number 11. Okay. Problem number 11. A conditional statement is shown below. If a quadrilateral has perpendicular diagonals, then it is a rhombus. Fair enough. Which of the following is a counterexample to the statement above? So they're saying if it's perpendicular diagonals, then it's a rhombus. So if we could find something that has perpendicular diagonals that is not a rhombus, then we have a counterexample, right? Then this would not be true. So let's find something with perpendicular diagonals that is not a rhombus. Well, this one has perpendicular diagonals, right? The diagonals are perpendicular to each other, all 90-degree angles. And this is clearly not a rhombus. This is like a kite. And I mean, this is not parallel to this, and that is not parallel. So this is not a rhombus. So this is definitely a counterexample. This one does have perpendicular diagonals, but it's also a rhombus. So it's not a counterexample. It's just an example of what they're trying to say. This has perpendicular diagonals. It's a square, but a square is a subset of rhombuses. So this is just another example. And of course, this one does not have perpendicular diagonals, right? This is not a right angle. Anyway, so A is the counterexample. Next question. Problem 12. Problem 12. Which triangles must be similar? Which triangles must be similar? Two obtuse triangles. No, obtuse just means that they have, two angles. Both of them have angles that are, one obtuse angle might look like that, where that is greater than 90 degrees there. And then the other obtuse might be super obtuse. It might be like that. It might be super obtuse like that. And clearly these aren't similar, where this angle is obviously larger than that one. Okay. So this is not similar. Similar means all the angles are the same. So it's like congruent, but you can scale them in size. That's how I think of them, right? Like this triangle, it could be congruent to, I'm trying to draw it so it looks exactly the same, that triangle. Well, no, but you can imagine that. Imagine if I cut and pasted that, right? But it would only be similar to this triangle if I drew everything to scale. Because the sides are different sizes, but all the angles are the same. That's what similar means. So let's see. Two scalene triangles with congruent bases. With congruent bases. Well, no, that's not true, because I could have, that's not similar, because let's say this is their base let's say they share the same base. Right? One scalene triangle might look like this. Might come out a little bit and then go down like that. right? And then the other scaling triangle, let's say it has the same base right there, it might be something the sides might be a little bit closer to each other, right? So clearly these two things aren't similar. This angle is different than that angle. All the angles are different, so they're not similar triangles. So that's not right. Two right triangles. Do those have to be similar? Well, no. You could have a right triangle that looks like this, where maybe the two sides are equal, right? That's a 45, 45, 90 triangle. Or you could have something like this, where you have a 30, 60, 90 triangle. These clearly are not similar. All the angles are not the same. They both have a 90-degree angle. So I'm already guessing that D is our right answer, but let's see how it works out. Two isosceles triangles with congruent vertex angles. Two isosceles triangles with congruent vertex angles. So I'm assuming when they say congruent vertex angles, I'm assuming they meaning all of the angles are congruent. Maybe I'm So two isosceles triangles. Let me think about it a little bit. Two isosceles. Oh, actually, I think what they mean the angle in the middle when they say vertex angle. So, well, if that's one of my isosceles triangles, that's one of mine. An isosceles triangle means that that side's equal to that side and that angle is equal to that angle. The vertex angle, I'm guessing they mean is this angle right there. So if I had another isosceles triangle, let's say maybe it was a little bit smaller. Say it looks something like that. And the vertex angles are the same. If that angle is equal to this angle, well, if that angle is equal to this angle, and we know it's isosceles, so if we know it's isosceles, that's equal to that, then that has to be equal to that. We know that all the angles are the same. How do we know that this angle is equal to this angle? Well, think about it. Whatever angle this is, let's call this x, right? And let's call this angle y and this angle y. We know that x plus 2y is equal to 180, right? Or that 2y is equal to 180 minus x, or y is equal to 90 minus x over 2, right? Now, if this is x, and let's call these z and z. So we know that x plus 2z is equal to 180. All the angles in a triangle have to add up to 180. Subtract x from both sides. You get 2z is equal to 180 minus x. Divide by 2. You get z is equal to 90 minus x over 2. So z and y are going to be the same angles. So all the angles are the same. So we're dealing with similar triangles. So choice D was definitely correct. 13. Okay. Which of the following facts would be sufficient to prove that triangles ABC, so that's ABC, that's the big triangle, and triangle DBE, so that's the small one, are similar? So we have to prove that all of their angles are similar. And I can not even look at the choices and I can guess where this is. So we want to prove that those are similar. So first of all, they share the same angle, right? Angle ABC, this angle, is the same as angle DBE. So they share that same angle. So we got one angle down, right? And now let's think about it. If we knew that this angle was equal to that angle, and that angle is equal to that angle, we'd be done. And the best way we could come to that conclusion is if somehow, if they told us that this and this are parallel. I'm guessing that's where they're going. Now, I might have gone on a completely wrong tangent, because if those are two parallel, then these two lines are transversals of the parallel. So that and that would be that line, that angle and that angle would be corresponding angles, so they'd be congruent. And then that angle and that angle would be corresponding angles, so they'd also be congruent. So if they told us that these are parallel, we're done. These are definitely similar triangles. And sure enough, choice C, they tell us that AC and DE are parallel. These are parallel. That's a transversal. This is a corresponding angle to that, so they're congruent. This is a corresponding angle to this, congruent. So all of the angles are congruent. So we have a similar triangle. Problem 14. Okay. Parallelogram ABCD is shown below. Fair enough. Parallelogram, that tells us that the opposite sides are parallel. That's parallel to that. And then this is parallel to that. Okay, and all the choices got clipped at the bottom, but I'll copy them over. Maybe I'll copy them above the question. Well, let me see what I can do. If I pasted it there, I think that's good enough. A little unconventional. Okay, parallel is shown below, and they say which pair of triangles can be established to be congruent to prove which pair of triangles can be established to be congruent to prove that angle DAB is congruent to angle BCD. So they want us to show that DAB is, so DAB is this. Let me do another color. DAB is that angle, is congruent to BCD. So they want us to show that those have the same angle measure. Okay, and what do we have to show? And they say what pair of triangles can be established to be congruent to prove that? Okay, so we have to just show two. If these are both part of two different congruent triangles and they're the corresponding angles, then we know that they're congruent and we'd be done. So let's see what they say. Triangle ADC and BCD. ADC and BCD. BCD has this angle in it, right? BCD, it does help us because it has this angle in it. But triangle ADC does not have this angle in it, right? Triangle ADC has this smaller angle in it. It has this. ADC doesn't involve this whole thing. So that's not going to help us. Triangle AED. AED, once again, does not involve this larger angle. Does not involve the angle DAB, right? It only involves a little smaller angle. So that's not going to help us. Triangle DAB, that looks good. That has this whole angle in it. DAB. And then BCD. Right. If we show that that triangle is congruent to this triangle right here, I think we're done. That would be enough to show that this is congruent. This angle is congruent to that angle because it would be the corresponding angles of a congruent triangle. So I think C is where we're going to go. Let's just look at choice D. DEC. DEC. Once again, DEC, triangle DEC. Let me make this point clear. Triangle DEC does not involve either of the angles we care about. It clearly does not involve this angle, and it only involves part of this angle, only this part. It doesn't involve this whole angle. So that's not going to help us either. So the answer is C.